Welcome to Digital Health Disruptors, a podcast brought to you by Charm Health, where clinician entrepreneurs and technologists come together to share raw, unfiltered stories of how they're disrupting healthcare and shaping the future of digital health. Hello, disruptors. Welcome to Season 2 of the DHD podcast. Today, my guest for this episode is Dr. Divya Chander. Her resume reads like a who's who of top-tier institutions: Harvard, UCSF, UCSD, the Salk Institute. Right now, she's the chair of neuroscience at Singularity University and a visiting scholar at Stanford. She's also a physician, neuroscientist, futurist, and the co-founder of Lucidify, a startup in stealth mode focused on detecting delirium by continuously monitoring the brain using machine learning algorithms on edge-based devices.
Delirium seems to be a final common pathway or a biomarker for organ failure in your body. So they have fluctuating levels of consciousness. They begin to hallucinate, have nightmares, or they will just withdraw into this sort of black box of their head that is no longer getting normal sensory input. Their brains are actually functionally breaking down. If you're over the age of 65 and you go into the intensive care unit, your chance of developing delirium is 70 to 80%. And so people who have untreated delirium die at 3 times the rate of all causes. But if they don't die, you may accelerate the development and the full expression of that dementia by up to 20 years.
In today's episode, Dr. Chander will discuss her startup and how she uses EEG technology to determine when the brain loses and regains consciousness. Her expertise in neural signal processing has led her to develop mind-reading algorithms. She'll discuss her plans to not only read the brain, but also write to the brain, with the goal of improving cognitive health and longevity.
Almost all technologies to treat chronic disease potentially have the possibility of de-aging, bringing cells back to a more youthful place.
We'll also delve in how the hurdles of her previous failed startup becomes a turning point for her, challenging her to redefine her values and sharpen her mission. And on a personal note, she shares the role of a key mentor, Dr. Bill New, a figure who not only inspired her to think differently, but also guided her journey from becoming a clinician to embracing the entrepreneur mindset. Stick around. This conversation is one you don't want to miss. Hi, Divya. I am so excited to start today. I have so much to unpack, and I've been looking forward to this podcast for a really long time.
As have I, actually. So let's have a fun conversation.
As a child, I remember picking up the Bhagavad Gita and reading several pages about consciousness, calling it an essential marker of the self. So as a researcher and anesthesiologist, neuroscientist, you see the brain in different states of consciousness, like sleeping and coma and under anesthesia. In your definition, what is consciousness?
Like you, I would pick up books from my parents' bookshelves and a little bit of the Vedas here and the Gita here. I've always been interested in this problem of consciousness, and I wanted to study it in a way that was rigorous as well, not just through inner experience. Consciousness is not a unidimensional thing. A lot of people conflate consciousness with the contents of consciousness. So all these things we've been talking about, the things that we hold in our conscious awareness, our ability to process things, that's not all that makes us conscious. When it came time to choose my medical discipline, I chose anesthesiology because there I could make people reversibly unconscious for a living and study their brains in the process. And if you have a way of recording the brain during that process, you can say something about those underlying neural networks. And in fact, when we give anesthesia drugs, we modulate level of consciousness from being awake and aware to being, say, drowsy, then to sleeping, then to comatose, and then all the way through brain dead. We can not only do this in humans, we can do this in every animal we have tried. You can even do it in fruit flies. So here I am enamored with these studies of consciousness in the operating room. And I will say that I was measuring people's brain waves in real time. I actually titrated anesthetic drugs to their brain. So instead of having to guess what somebody would need, it was sort of a precision medicine function. There is a signature of a well-anesthetized brain that is unconscious, but in the Goldilocks zone. So not too deep, not too light. They're not going to have awareness. And I would just give them drugs to exactly keep them there. If they look like they were getting too light, I would give more. If they look like they were going too deep, I would back off. And so you could even time things and they would have these beautiful wake-ups. I also started using my eyes for biomarker discovery. I would look at the screen on my EEG and I'd be like, this person isn't going to wake up well. And I could even change what I was doing anesthetically with my medicines to improve the outcome afterwards.
Understanding consciousness, where does delirium fit into the picture?
So great question. The best catch-all phrase for it is acute brain failure. It's failure of the organ. And if you look at patients with delirium and you actually measure what's happening in their brains, it's doing what they do under anesthetics to some extent. Their brains are actually functionally breaking down. I'm not giving them an anesthetic drug, and yet their brains are beginning to look like I have. And if somebody has delirium, one of a few things is happening. There's acute neuroinflammation, which often means that it's a biomarker for something like sepsis, right? Or organ failure, which is why they die of all causes at 3 times the rate. But if they don't die, their chance of developing dementia goes up 13-fold. So let's say you had a predisposition to developing dementia, and now you go to the hospital for, I don't know, you had a hip fracture. You end up in the intensive care unit, and then you get delirium, which there's a very high likelihood you will. You may accelerate the development and the full expression of that dementia by up to 20 years. So if you were supposed to get it at 92, you may get it at 72. Let's say their brains get better and they seem to be able to be discharged. Many of those people never go home again. And so they've lost their agency. They become institutionalized. So they go to a nursing home. The faster you treat it, the more chance you have of saving their life, saving their brain, and making sure they don't end up in an institution.
The reason they get worse after going into the hospital, that aspect of it I'm missing. Why is that? Is it the anesthetic and that breaks down their brain?
Great question. We are not sure that it's the anesthesia at all. We think it might be the surgical insult alone that causes delirium afterwards.
The stress. Okay.
Yes, because it's a major stressor response. Think of delirium in some sense as a catch-all syndrome. So it's going to have different phenotypes. There are delirium researchers out there who are really working hard to understand all the different things that can actually lead to it. But the final common pathway is the brain is breaking down functionally. They result in the same thing. And that's why I like to think about it as a biomarker for these other things.
The term delirium comes from the Latin delirare, meaning go off the furrow, an old metaphor for straying the path of reason. For centuries, delirium was shrouded in mystery and fear, often labeled as divine punishment or the result of demonic possession. Treatments were more about rituals and religious interventions than medical care, fueled by the belief that the mind has been overtaken by supernatural forces. Fast forward to today, delirium is recognized as a complex neuropsychiatric syndrome with real physical roots, often triggered by factors like illness, medication, or withdrawal. But even with all our advancements, delirium still holds its secrets. It's an area of ongoing research where scientists are racing to crack the code behind its mechanisms and fine-tune treatment strategies. Why does this matter? Because if left untreated, delirium doesn't just vanish. It can leave lasting scars on brain health, affecting cognition and memory long after the episode is over. But what is the current standard of care for delirium?
If you have an intensive care unit that is operating under standard of care, which is a questionnaire, which picks up a few features of delirium, it's called the CAM-ICU, and they're doing it reliably. They're doing a bedside evaluation according to the DSM-5. And somebody does present as delirious, that clinician will now begin to go through a process. Our caregivers are supremely overburdened, right? They have a lot to do. That they don't do the standard of care, which is to screen for delirium a minimum of once a shift. And it's so subjective anyway that if they don't do it often, the chances that they'll detect it are really low. Plus, delirium waxes and wanes. It's not like dementia where there's like a baseline and then sometimes people sundown in the evenings and they get a little worse. It doesn't have that kind of circadian cycle. It just goes up and down and up and down. And the worst is 80% or so of delirium is hypoactive, where the person just looks withdrawn. And if they don't even participate in the bedside evaluation, people write them off as being old. And if you're over the age of 65 and you go into the intensive care unit, your chance of developing delirium is 70 to 80%. It's really high. The faster you treat it, the more chance you have of saving their life, saving their brain, and making sure they don't end up in an institution.
The direct antonym of delirium is lucidity. Your company's name, Lucidify, has that sense of calm and clarity, like a serene sky after the storm has passed. How does Lucidify then address this gap?
Yeah, so that's a beautiful question. What Lucidify does is it provides 24/7 continuous brain monitoring, but in a form factor that is tiny. They're not tethered to all these monitors and devices. We're not building something that's wired at the moment. And it does its own machine learning and processing at the edge so it can detect the signal of delirium before any human has a chance to even evaluate. And then it sends them an alert. So they come and then they go downstream and do all the things they're supposed to be doing to abort delirium. So by early detection, you also get them out of the hospital faster. So that saves them from getting exposed to other patients and infections. For instance, it can decrease length of stay in the ICU by 6 days or more. With value care, bundled care, if you go in for a hip fracture, you're only going to get a certain amount from Medicare. That's it. The hospital eats the cost of every additional day of resources. So the hospital wins, the patient wins, the family wins.
The insurance company wins too.
Yeah, it costs like $245 billion a year to the U.S. healthcare system. And that doesn't even include the dementia part, almost as expensive as diabetes. These patients are very resource intensive. I think it's 7 medical societies petition Medicare to make delirium a major comorbid condition. And if it is awarded that designation, it modifies the DRG, the sort of the category, and there is an increase in reimbursement. So we are finding ways to incentivize hospitals to do the right thing. You pick up delirium early, you not only save the patient, but you get more money.
Brilliant.
And you save money because you got them out faster. Basically, the business model writes itself. There are enough clinicians out there that recognize what a burden delirium is, how much suffering it causes, but also how expensive it is resource-wise. And then for the patient, the pain and suffering, think about their families, right? And many of them, they go to skilled nursing now where they end up in memory care. It's the entire sort of follow-on effect for the entire U.S. healthcare system. It's the most common, costly, deadly syndrome you've never heard of.
Wow. Just not enough publicity. I guess this is why you call it the silent killer.
Yeah, the funny thing is, though, when I talk to somebody and I describe what it is, 1 out of every 2 people has a family member or themselves experienced it.
Up next, Dr. Chunder breaks down how she's challenging conventions with advanced sensors and edge computing, pushing boundaries through clinical trials and collaborating with leading experts to drive breakthroughs. She also shares her bold vision to reshape cognitive longevity and redefine the future of brain health. Where are you currently in the journey of building your startup, Divya?
Well, our goal is to try to do as much processing at the edge because the chips are getting so much better. When you do things locally, you can do them more in real time. We're working through this process right now. We're about to run a clinical trial with one of the world's biggest delirium leaders, and I'm super excited to do that. He was the past president of the American Delirium Society. And we're going to actually try 3 different algorithms and see which one gives us the most precision in measuring delirium. And if they all do equally well, we'll choose the one that uses the least power. I have already started the process of going through FDA regulatory. Now I have a formal regulatory advisory group. And so they're baselining the product and its different manifestations. They're going to help me come up with a strategy and make sure that my clinical trial design is exactly what the FDA is looking for.
This is a non-invasive design. This is just a sensor that's sitting on your forehead or behind your head. Why does it matter that the FDA is involved at all?
Yeah, this is a great question. You could sell in the consumer space, but you can't sell it to the hospital. They're trying to protect the patient, right? So they want to make sure it's safe. So how could we hurt a patient? I don't know. Our adhesive causes a rash or something, and we need to know.
Yeah.
Or maybe the electrodes, because they're electrical components near the head, they want to make sure they're not going to burn the patient's skin. Artificial intelligence now is coming into all of this. And why is that important? If my software, let's say it's for cancer detection, and it says you have cancer and you don't, I have subjected you to needless suffering. I have subjected you to needless tests, many of them potentially invasive, cost the entire healthcare system money. If I don't pick it up, so it's a false negative, then I may have accelerated your chance of dying and not treating you. So software is actually as important as the device itself. So we do have to get some kind of FDA approval.
For Lucidify, this focus allowed them to tap into the FDA's Breakthrough Devices program, which is designed to fast-track approval for innovations that significantly improve patient care. You spent a considerable amount of time using EEG technology in your clinician practice. Is this utilized in Lucidify to monitor and interpret the brain activity?
There have been a few that have shown that if you do like the things that people associate with an EEG, like a big cap, it's called the 1020 system, or 21 electrode.
Right. Yeah.
There are very definite correlates in the EEG, and there are all kinds of ways. So I've actually found ones that are different than even the ones they identified.
Dr. Chunder is building Lucidify in stealth mode. Though she stayed tight-lipped, she shared glimpses of her progress and the challenges she's overcome. My understanding is that you're using a non-invasive brain-computer interface, correct? Which is super small or very usable. You're able to place it somewhere on the head and be able to detect the EEG patterns?
Yes.
And is that small?
If one part of the brain looks exactly like the next part of the brain, there's no calculation of information taking place. I learn nothing. The brain is learning nothing. The brain is computing nothing. And so when your level of consciousness becomes depressed, your brain looks like a mirror image of itself. And that's why I can do what normally takes a 1020 system to do. I can do it with very few electrodes. I want the signal that tells me the brain's failing, and I know how to do it. And I would not lie to you and say, you can do all flow states and you can do this attentional thing. You can't do that with a few leads. You actually need a denser system. Anything where I'm taking away your consciousness or diminishing it in some way.
What Dr. Chunder has been working on might one day prove invaluable in recovery from traumatic brain injury or even an opioid overdose. The simplicity of the approach is its power, a possibility that could transform lives and offer hope in the face of devastating challenges. The proprietary part is using your algorithm to detect the delirium using these sensors.
These sparse sensors, yeah. Yeah.
Okay. Understood. That is the part that is patentable, proprietary, and the secret sauce of...
Some of it's secret sauce, some of it's patentable. Our MVP is not as focused on form factor yet. Our MVP is the algorithm. And in that process, iteratively, we're going to learn from our users what I predict is the right form factor.
Last time we spoke, you were looking for specific sensors, and you said that the technology hadn't yet developed. You know it's going to be in the next 2 to 5 years.
There are huge improvements in bioelectronics today. While the first version of the product is going to be using existing electrodes, for instance, existing electrodes are maybe less flexible or less comfortable. They might require more power for amplification. So electrodes are becoming thinner, more flexible, less power hungry. And those are the kinds of changes that I'm looking to implement. So the beginning is the form factor. And then the second is all the things that make it more comfortable. So it just disappears. So that's what I'm looking to do. And I actually don't think we're very far off. Not everything is fully commercialized, but there's a lot of really cool bioengineering labs around the country and around the world that are building these flexible electronics, and I intend to use them. So
there's no stopping you, Divya. It's like candy for you. You're using your algorithm to be able to read delirium. And so therefore, once you're able to read it, then you can take it to the next level, right? So then are you able to then write to the brain?
Fabulous question. Yeah, so it's on my roadmap. I'm so glad you asked. This is the part that I'm not going to get as deeply into, but there are already ways. For instance, I can do things like decrease inflammation in the brain using neuromodulation. And so a little bit further down the line, I want to create a closed loop BCI.
That is when it's exciting.
If I can do that for patients with delirium, there's no reason it wouldn't work potentially for anybody who wants to increase or improve cognitive longevity, right? So that moves out into a different market now.
By identifying when the brain is breaking down, you're helping prevent it. And when you're right to the brain, you're actually, again, rejuvenating it.
That's what we're hoping. Exactly. Okay. And in patients with delirium, because they're starting from a lower place, you might be just bringing them back to their baseline. This is more of a general principle. Almost all technologies to treat chronic disease are also inherently longevity technologies, because if you use them in somebody without the disease, you potentially have the possibility of de-aging, right? Or bringing cells back to a more youthful place.
Coming up, Dr. Chunder dives into what sets her startup apart from the competition. Is it all about having groundbreaking algorithms, or does it boil down to creating tools that clinicians genuinely want to use? She also opens up about the game-changing influence of her mentor, Bill New, a Stanford anesthesiologist and electrical engineer who didn't just invent the life-saving pulse oximeter, he fiercely pushed stakeholders to adopt it. And finally, she shares how staying true to her values and mission became her compass, helping her navigate the highs and lows of startup life. Who would you consider to be your biggest competitors?
There are two companies. Both of them are spot checks. So neither of them can do what we can do, which is continuous brain monitoring. That is really, really important because I mentioned it waxes and wanes. If you come in and you're trying to get a spot measurement and the person's not delirious at that moment, it's just like doing the bedside exam. You might miss it, right? They require cooperation from patients. And in someone's delirious, that's not always easy to get. So it fails in the same way bedside exams do. The thing that we know that nobody else is doing is recognizing the deep, deep importance of this form factor, this usability. They've got algorithms, etc. But even this alone is enough to have us outcompete them at the moment. It's as important, if not more important, than the algorithms themselves. Because, like I said, you can have the best algorithm in the world. If nobody uses it, you have nothing.
70% of healthcare professionals in a Deloitte survey said that the usability of a medical device is one of the top factors they consider when recommending or adopting new technology. Simple tools minimize the risk of errors and let you adapt quickly. When Dr. Chunder spoke with potential users, it was clear that they want technology that feels as straightforward as using a blood pressure cuff or pulse oximeter.
Do not make too many assumptions about what people will use. Go out and ask them. And that's the whole customer interview part. If you do not do that correctly, if you skip that part, there is an 80 to 90% chance you will build something that will never sell. There will be no market for, no one will use. It absolutely doesn't matter if it does what you think.
Dr. Chunder opens up about the Stanford anesthesiologist who completely changed her path and still inspires the way she tackles innovation today, showing just how life-changing the right mentor can be.
This mentor I had, who was also previously a Stanford anesthesiologist, when he was younger and at Stanford in the 80s, we didn't use pulse oximetry. So we had no way of measuring someone's oxygen saturation, even though we're sticking tubes into their lungs and ventilating them. And so he built a box and he brings it into the OR with him at Stanford. And people think he's absolutely lunatic. And then he starts telling his colleagues, he's like, oh my God, I'm noticing that when I thought my patients were fine, they're actually desaturating with this thing I built. And everybody's looking at him like, you're nuts. My patient's not blue. He's like, no, they don't get blue until they're like 50%. That's really bad. It's like brain cells are dying at that point. Anyway, so he couldn't convince colleagues. He brought it to the American Society of Anesthesiology and he said, hey, I think you need to make this a standard monitor. And they were like, similar reaction. And he said, look, if you do this, you can take credit for having made it a standard monitor. If you don't, I will take it to the media and tell them you're killing people. And apparently they listened. Now, again, this is a story. This is hearsay. His name was Bill New. He's passed away now, but he is the first person to have commercialized pulse oximetry in the United States. And he had some of the very earliest patents in pulse oximetry. And so we have pulse oxes thanks to him.
A bit of arm twisting. What a hero, right? Mm-hmm. And he had a ripple effect impacting you. He seems like he was a firecracker. And Divya, you're like dynamite too. You're like intelligent, passionate. And I think he could identify one of his own kind, to be honest. In search of an anesthesiologist with EEG expertise, Bill took Dr. Chunder under his wing and became her mentor, shaping her journey in ways she hadn't anticipated. Then, one day, Bill said something that stopped her in her tracks. Words so impactful, they shifted the entire trajectory of her life.
I showed him all the work I was doing. And I says, I'm sure you're a great anesthesiologist, a brilliant one even. He says, but there's a lot of great anesthesia clinicians out there. He says, you are working one patient at a time. If you want to impact millions of lives, millions of brains, you're going to need to commercialize this. You're going to need to find a way to expand this. And that set me off on a journey, including a startup class at UCSF. You know, there are people who actually, when they see talent or desire or motivation, they actually feel competitive. Like, this is my space. He was completely the opposite. He just wanted to nurture that. He is way up there. You know, I would never have thought to ever build something commercial had it not been for him. I didn't even think it was possible. I was an academic. I came from an academic clinical family. We didn't do things like that. And he changed everything for me. When I went to his memorial, there were so many people who talked about how he mentored them. And so let's just acknowledge what a wonderful soul he was. It's not always who you think it's going to be. It sounds kind of weird, but you have to be vibrating with this resonance that you'll actually attract the mentor to you. You'll start vibrating on the same frequency. Almost felt like that's what happened with me and Bill.
Discover the Charm Health platform, a perfect ecosystem where technologists and clinician entrepreneurs connect, ideate, and thrive. Visit us at charmhealthchallenge.com. An entrepreneur's path is never simple, and Dr. Chunder realized this firsthand. One surprising lesson she learned: her core values were key in choosing the right direction.
So the previous company I had was actually a cyber health security company. We were implementing an alternate internet architecture that we were going to be using to secure patients' data. We also had this idea of giving patient back these healthcare data vaults, et cetera. In the process of trying to raise capital, there was a chicken egg thing where they wanted to see a certain prototype, but we needed the capital to build the prototype. And then one of my co-founders got the brilliant idea that, well, why don't we just sell all this data to Big Pharma? And he's not a bad person. It's a very common business model, but it was not a business model I wanted to be part of. The whole reason I was doing this is because it was a much more secure system. And I wanted to empower people to get their data back. That did not end up working out.
You strongly feel you have an ethical duty to preserve the patient privacy, and you want to give back their neural rights. There's just this simple misalignment in values and principles, which you probably didn't think about when you first met him, and you didn't realize. And so maybe one of your learnings was, well, maybe you need to align on these basic principles.
I knew that this wasn't why I went into it, and I kind of wish we were on the same page. You know, I knew it might be a rapid infusion of cash, but it wasn't like the way I wanted to get the rapid infusion of cash. When you're in the healthcare space, digital health, even if it's consumer space, you have to be very, very careful because you are collecting the most sensitive data about people. It's like they're very self. This is what you're collecting about them. And to get this offhand data so we can improve advertising or income, that has absolutely no integrity for me. My CTO and I resonate at such a high frequency. We were co-medical advisors at the Extended Reality Safety Initiative. We're all about data. This is why we're a badass team. Our passion for making all this data work at the edge means that at some point, Ryan and I are going to be able to take all of what we're building for delirium detection and be able to give people their data back so that they can carry it around with them.
So the data that you're collecting with respect to delirium and within the scope of Lucidify, how do you intend to have that patient data protected?
So I have a very strong ethical commitment to not reading from or writing to someone's brain without consent. But what happens to that data is another big piece of it. But we are getting to the point where we can reconstruct what people are seeing, hearing, tasting, and what they're thinking. Neuromodulation technology is getting better, so we can also rewrite underlying circuits. I know my ethical principles. I know we're trying to build them in the ground up. We don't want to band-aid them afterwards. That's a really important piece of it. And we also know that we don't want to hold, store, or bank any data that we don't need to. And that's a big mistake a lot of companies make. They think, the more data we collect, the better off it's going to be because at some point we'll be able to use it. But they don't know how to secure it.
You're so passionate. That passion actually is very contagious. How are you different from other thought leaders in your space?
My world was made up of people who were involved in space and rockets. And then the people who were the neuroscientists, they were really into the brain. And then I spent a lot of time in academic institutions. These different pathways brought me different experiences. And then I got suddenly exposed to this massive international business community and to governments. And then I started mentoring startups long before I went into creating my own company. And I started being hired to do due diligence for venture capitalists and angel investors. And then I got involved in exponential technologies and think tanks. And then I became friends with not politicians, but all the civil servants who underlie all of that, the deep state or whatever they call it, but really good people. I know a lot of people now in the FBI and the CIA and the DOD and the DOJ and the CIA, you name a 3-letter word, and I've met them. And it's expanded my network. And so every step of the way, I think differently. I think so differently than somebody who does not have all these parallel exposures. And so I have been able to bring in so many disparate parts of my life into the thing I happen to be focusing on.
And I'm sure in Lucidify as well, you're converging your ideas together to be able to create something bigger, more impactful.
You can be really immersed in a lot of different disciplines, but you can still develop a deep amount of expertise. I bring my neuroscience into anesthesia, which most anesthesiologists won't be able to do because they don't have a PhD in neuroscience. And I bring my meditation practice into it.
So where do you see yourself in 5 years?
I see us having developed a device that is in so many hospitals across the world, basically turn the EEG into a vital sign. And we use it to help triage patients and save brains. And maybe do things like deal with opiate overdoses or send into space for astronaut brain health and things like that. And then finally, I have been trying to devote a lot of my time to my internal development. I am trying to take the discipline of my meditation practice more seriously. That's a really important piece of who I am and why I'm here. Besides, that is not part of all these external trappings. That's really my consciousness with a big C here. So
that's big C. I just love your story. Your story is exactly what I hope to inspire our clinicians. And using Lucidify as our backdrop, your PhD background as a neuroscientist and applying it to your life as an anesthesiologist to really the next level, and then taking the advice of your mentor. I mean, you could have just left your advice alone and not done anything with it. So thank you, Divya, for a fascinating discussion today. And for those listening, you can find Divya Chander's contact on LinkedIn.
There's a way to connect on my website.
And that's divyachander.com. And that's a wrap on today's conversation with Dr. Divya Chander. Her journey with Lucidify is nothing short of inspiring, blending bold ideas, stealth strategies, and a relentless drive to reshape healthcare. It's not every day you meet someone who seamlessly combines neuroscience, technology, and a visionary outlook to tackle some of healthcare's toughest challenges. If you've enjoyed this episode, don't forget to hit subscribe And more importantly, share it with anyone who loves a good innovation story. And hey, keep an eye on Lucidify. You might just be witnessing the next big leap in health tech. Until next time, keep dreaming big, breaking barriers, and chasing that next great idea. Thanks for tuning in.